All right, do you have questions about your homework before I start? I am so sorry I wasted so much time today. That is not like me, and I'm sorry. Wasting time is boring. All right, everybody okay? It was pretty straightforward with the graphing and finding the zeros, right? All right, guys, come on, Grayson. You're causing. All right, we're gonna do a little Algebra 1 recap lesson before we solve with radicals. So I know y'all love radicals so very much. Everybody does. But I need to review you on a couple of um, ways that we work with radicals. Before. Yeah, for right now. The next title is going to be solving with radicals. All right, so let's say I have, first of all, tell me what a square root is. What does it do? What's it mean? It's that thing right there, but what does it do? Like if I put a 25 under here, what? Tell me, somebody who had no idea what that meant, how would you explain it to them? No, not just what the answer is, but there you go. What two seven same number multiplies together to give you what's under there, right? So it's 5 and 5. Y'all all hollered it's 5, and you're exactly right, it's 5. But what if I asked you something like, you're actually really close. You're doing it in your head. You don't, but you're not really saying what you're doing. I know what you're trying to do. You're simplifying it, right? And in the process of simplification of a radical, tell me what you do. Well, there's not two though, right? No two same numbers multiplied to 50. That's exactly right. We look for the biggest perfect square factor of what's under, and then we split the radical up. So in other words, if I think about perfect squares, and sometimes when I'm working with these, I'll kind of make a list over to the side. 2 to the second is 4. 3 to the second is 9. 16, 25, 36, 49, right? We all know our perfect squares, yes? And this should be a review. You should have done this last year in Algebra 1, maybe even prior to that. I'm in 8th grade. Okay, so maybe you don't remember. I want the biggest one I can divide it by evenly, which would be 25, right? 25 times what gives you 50? 2. So radicals have this neat little property that says if you multiply under the radical, then you can split it up into two different radicals. So this could be the square root of 25 times the square root of 10. 2. Does that make sense to everybody? So that now we know the square root of 25 is what? 5. And then the square root of 2 stays. Now I do want to make sure I throw a plus or minus in front. Why? How could it possibly be negative? And it's easier to explain with this one up here. Negative 5 times negative 5 is also positive 25, right? So I need a plus or minus in front. All right, do y'all remember simplifying radicals? Yes, I hear yes and I hear no. Let's do another one. I hear no. Okay, this one's for you, Grayson. Hold on. Let me get one that works well. Simplify the radicals. I'm gonna change this to 8. Simplify the radicals. Grayson doesn't know how. Stumped him. He stumped. Anybody know how? What's the greatest? Okay, you might not have done this in 8th grade, but you were supposed to do this in 8th grade. Let's ask her. All right, that was fun. 135. What's the perfect square you can take out of it? 9. 9 times what? 15. This is multiplied in front, so I'm going to keep it multiplied in front, but I'm going to go 9 and 13 here. What? And remember, all this is being multiplied, right? And I usually do this because that's what I always tell kids. Like, don't forget to do this. And then they always know I'm talking about splitting up the radicals. Square root of 9 is... Oh, sorry, I just listened to y'all. Thank you, Finley. Thank you. I'll make sure nobody sits on you now.
Hey, let's catch you to getting the sophomore.
Why? Why? $24 root 15. All right. A couple of other properties that I want to make sure you know. You can split up multiplication like this. Could I split that one up? Could I say the square root of 4 plus the square root of 1? Because they're both perfect squares. Could I? Yes or no? Y'all look like you don't know what to say. I don't know, Miss Vicky. What's the right answer? All right, look, I can't do that. I'm setting you up. It does not equal. You can only split it up if you're multiplying, not if you're adding or subtracting. Okay, so don't ever do that. Be very careful there. Now, yes, but this you cannot make. I'm saying you can't split them into two separate radicals. Okay. Now you can split up multiplication, and you can also split up division. So you could make this the square root of 4 over the square root of 25, which would be what? 2 over 5, right? Or 2/5. When do I encounter a problem, however, with radicals until you get to calculus and it's no longer a problem? When do I encounter fraction-wise something with a radical, a problem? Negative under the radical, but what about with a fraction? If I split that up, what do I get? I can't do it, right? It's just square root of 3 over 2. Is there anything wrong with leaving it that way?
Yeah.
Because I'm asking you. You know there's something wrong because I'm trying to prod you to that, but you're just not getting it. You can't have a radical in the denominator. Y'all don't remember doing this? It's called rational. Maybe I should just send you down to get it. All right. Square root of 2 cannot be in the bottom. I can't have a radical at all in the bottom, so I have to get rid of it. In order to get rid of it, I have to do what we call rationalizing the denominator. And all that means is multiplying it by something that will make it go away. Okay? What could I multiply the square root of 2 by to get the radical part to go away? Square root of 2. If I do it here, I must also do it here because really what I'm multiplying is 1. Right? Anything over itself is 1, so it's not changing the value of my fraction. Are y'all okay with that? Do y'all remember doing this? Well, I keep thinking if I do another little step, it'll jog something in your brain and you'll go, it hasn't. Okay. We're not jogging. Are we walking at least? We're running backwards. Okay. So square root of 3 times the square root of 2 is what? Square root of 6. I know I can put those together just like I can take them apart, right? So I got square root of 6 over, what's the square root of 2 times the square root of 2? Square root of 4, which is 2. So here's a little trick you don't have to put them back together and do. Anytime you have the same radical multiplied together, what you're left with is just what was under the radical to start with. Because that'd be the square root of 25, which is 5. If you had the square root of 7 times the square root of 7, that would give you 7. The square root of x times the square root of x, x. It doesn't matter what's under there, it's just going to go away.
I just took it. No, he took it out.
Bryson, this one's for you. Be careful because this one will simplify some. One of the radicals will simplify some. And you don't necessarily have to simplify it before you start, but I probably would because it'll make your multiplication. What do you think we should do first, Bryson?
Well, I think the bottom is going to be 2.
Did you figure that out in your head?
Yeah.
So Grayson says the bottom, the square root of 8, is 2 root 2 because you split it into 4 and 2. And he's exactly right. The bottom would be 2 root 2. How about the top? That he doesn't know.
Well, it would be 5 and 3.
5 is not part of square, nor is 3. That's the square root of 52. There's nothing else you can do with it. You leave it. But what's the problem? There's a radical in the denominator. How can I get rid of it? Square root of 2, square root of 2. What's the top become? How about the bottom? 4. 4. These two together make what? And there's already a 2 in front. What? Can I do anything else? Simplify the 30? How could I simplify the 30?
Maybe 15 over 2.
15 a perfect square? How about 2? Right, it's got to be perfect squares, right? Neither one of those are perfect squares? So it's 2. All right. You said you don't remember ever doing this, so that would only be like the third problem you've ever seen like that. The problem, so, not the problem, what? An elephant.
Up and right. No, right below the right. So up and right. Up, right. Back arrow, up, right.
Oh my God. All right. Remember I told you I was giving you a crash course in this from Algebra 1, because this was Algebra 1. This is not what we're using this to solve quadratics, because I told you that's what we're doing the whole rest of this unit, right? Solving quadratics. This isn't solving a quadratic. This is simplifying a radical. So now we're going to use simplifying radicals to solve quadratics, and let me show you what I'm talking about. This isn't hard math. And I tell him to come sit in first block. Huh? Don't come sit in first block, Anna says. We have enough distractions in first block. All right. Yes. You got it. How did you guess that? That was amazing. That was amazing. All right. Solving quadratics with square roots. So we've solved now two different ways. What were they? Factoring, graphing. Okay. All right. Let's say there is no b, but is it still a quadratic? Yes. It's still a quadratic. So instead of factoring or graphing, what do you think maybe I could do here to solve for x? Okay, that's going to make it equal 0. Is that going to help you do anything? That is what we did yesterday, but today's a new day and we're learning something new today. Subtract the 7. So look, here's how, and I want to tell you a little hint how you know this before we start. When you only see x one time, either you see only one x or you can get it down to where there's only one x in the problem. You always, from here, let's see, I'm going to say, or get one. And I'll show you what I'm talking about. You always want to sad math. What is sad math? It's the backwards order of operations. I hope whoever taught you to solve equations at least taught you this, right?
No, backwards 3 already.
PEMDAS, but backwards. Please excuse my dear Aunt Sally, but backwards. Okay. So what this does, this tells us the order because solving is the opposite of simplifying. So I'm going to go the opposite order. You tired, Finley? Oh, okay. That's your lot then? All right. So the first thing I want to do is take care of any addition or subtraction outside of x. What would that be? -7. Move it. You are hardly asleep, dear. 15 minus 7 is what? 8. Now what can I do? Square root. That's exactly right. This is, I almost called you Carter. This is Grayson's favorite radical to simplify. Do what? Oh, I didn't tell you. I'm sorry. That's right. Good. So how do I get rid? I just jumped right ahead because I'm. The opposite of a squared is a square root, and they cancel each other out. You're exactly right. And so now I can look at my answer here and I can simplify it. And this is the same one we simplified earlier, right? We said it's. Gosh, y'all are just teaching me all kinds of stuff. Now I am forgetting one thing here. What am I forgetting? Somebody said it. Plus or minus. Plus or minus.
What does that do?
What does what? The plus or minus do? Well, because I have this quadratic, right? It's crossing at these two different places. And if I leave one of those out, I've left off one of my solutions. Because remember, that's what I'm finding when I solve for x. I'm finding the x. If I leave off the plus or minus, then I only have half the answer. Does that make sense? Y'all ready to crank it up?
Hey, I think
We were late cranking it up, though. So. Give me a number. 17. How'd you like me? I think your hair looks nice today. All right. How many X's do you see written in here? 1. Don't start trying to FOIL this out or distribute or anything else. X is only in there one time. Start SAD mapping. What comes first? Add or subtract. That's right. Parentheses or less. I'm going to add the 5. I got, what's 17 plus 5? 22. Come up with a better number myself.
I would actually take 8.
All right, so what's next? What's next? Multiply. What am I multiplying? So multiply by 1/2. Well, I can't distribute through here because of this exponent. Okay, but y'all are making it harder than what it is. So I've heard a couple different things. Do I distribute this through? And the answer is I can't do that because of this exponent. Do I write this twice? And I would say no, because I don't want to simplify anything here. Can I distribute this exponent? No, because I would have to FOIL it out. That doesn't work. Remember, I'm SAD mapping. What you got? What are you going to add? So they're not like terms, so I can't combine them. Any other ideas? What you got? Why? You're exactly right. You are exactly right. I wish I had. Anna, see if there's a piece of candy in my middle drawer right there. I thought I had a couple little pieces right there. If they're not, throw them a piece. All right. Matthew, right here. I don't mean to make you work.
I don't mean to make you work, but this is my.
That's not your sweetheart. Give him his sweetheart. Are you okay with him taking your sweetheart? All right. I multiplied by 2 on both sides, right? Because in order to get rid of fraction, the fraction's being multiplied. I could divide by 1/2, but we don't like to divide by fractions. Instead of dividing by fractions, I multiply by, what's that called? Reciprocal. Whenever I flip it, it's a reciprocal. These cancel. The reciprocal of 1/2. So I flip the fraction over. All right, so I've got x plus 1 squared equals 44. Am I? I feel like this is slow. I'm sorry. No, you want me to talk? So, what should I do now? I feel like that sloth on Zootopia.
That was a good one.
Okay, what do I do now? Excellent. No, that doesn't make sense. How do I get rid of an exponent of 2? No, you didn't. The square root, if you ever have the square root cancels it out. All right, what do I have? I've got x plus 1. I got to break it down. You're exactly right. That's probably because I do get to break this one down. Somebody said it. 411. Sorry. It is 2 root 11, but we break it down in 4 and 11, and then 2 root 11. 2 root 11. I gotta subtract 1. That's exactly right. When I subtract 1, does that become 1 square root 11? The square root of 11? So y'all are telling me that 2 square root of 11 minus 1 equals the square root of 11. They're not like terms, so we can't combine them, so we just write them. I always say, if you can't do it, write it. You are exactly right.
Everybody thinks this concept like that.
Everybody thinks that?
Yeah. I don't know.
I talk too fast?
Fast. Everybody raise their hand so you feel that.
All right. Y'all did say earlier we need a plus or minus, and you're absolutely right. The plus or minus goes here. Be very careful. I think this direction, not that direction. It was you, Finley? Was it Finley? I thought it was. Good job. All right. Plus or minus goes here. Be very careful. Make sure you put the plus or minus when you do the radical. Okay. So if I had something that looks like this, I know that this is 2, but I wouldn't do 2 minus 1 and then do the plus or minus. The plus or minus would have to come at this point in time. So what this becomes is 2 minus 1 or negative 2 minus 1, and that's how I get my 2 answers. So sometimes I have to split them a little bit differently. Does that make sense? Only, yep, exactly. Only the number that has the radical. Tell me what you think.